Humans are used to being masters of their domain, but step into the ocean and you can quickly find yourself out of your depth and in another species' territory. For as long as people have been coming to Australian beaches, they've lived with the threat of shark attack. But as scientific understanding of sharks advances, innovative technologies offer surprising new ways to coexist with these ancient killers. Few things inspire fear like the threat of shark attack. Sharks strike from beneath, seemingly at random, causing terrible injuries and taking lives.
Historically, shark bites have averaged around 10 a year, of which 1 or 2 fatalities. That has increased substantially in the last decade.
Of the 20 people bitten by sharks in 2020, 8 were killed, the highest number of deaths in Australian waters since 1929. As warming weather brings more people to the beach and warming waters draw fish and sharks into new territory, attacks are becoming more frequent. So how can we protect ourselves from sharks? For decades, beaches in the state of New South Wales have been ringed with nets and baited drum lines to keep deadly sharks out. Shark nets and baited drum lines function like huge static fishing devices. And in the last 60 years, they've caught almost 1,000 sharks, reducing the number of attacks by up to 90%. While effective at keeping people safe, they've had a devastating effect on the environment, killing 15,000 other marine animals, including whales, sea turtles, and dolphins.
Obviously, shark nets are old technology. They've been around since 1937. What can we do to actually reduce our environmental impact on the marine environment while still providing protection from shark bites?
Taking a forensic approach to investigating shark bites, Vic Pettimores and his team seek to understand how best to defend against shark attack.
I'm probably more concerned than the average surfer because I investigate all shark bites. So I see all the wounds, I deal with the victims, I deal with the families.
Understanding how shark attacks occur is crucial, but often there's little evidence to go on.
It is incredibly rare for the person that gets bitten to see the shark beforehand. It's very difficult to understand what was the shark doing, how did it approach, and what was the motivation behind the bite.
To understand why sharks attack, scientists first need to understand their physiology. This Port Jackson shark has been sedated and is being stimulated with different kinds of light. Scientists are able to measure reaction to brightness and colours, and it turns out that sharks see the world very differently to humans. Like human eyes, the eyes of a shark are composed of rods and cones. In human eyes, cones allow us to perceive colour, but the cones in sharks' eyes are dedicated solely to helping them deal with bright sunlight.
They are really well adapted to being able to develop their vision in both high light and low light intensities.
This allows sharks to hunt in the dark depths of the ocean and also in the bright water close to the surface, but leaves them effectively colourblind.
When they're looking at their prey, they're primarily looking at a silhouette, but they can distinguish that silhouette against the bright light really well. So the vision of a surfer paddling is very, very similar to a seal swimming with its flippers slightly out.
The shark singles out a target. As it closes in to attack, It relies on a sense that is totally alien to humans.
As they get closer, they are able to detect these tiny electrical fields.
Arrayed along the shark's snout are a sophisticated system of electroreceptors known as the ampullae of Lorenzini. They are so sensitive they can pick up signals as low as 1/1,000,000th of a volt.
You can imagine the heartbeat of a fish. I mean, that's hardly anything.
Whether through the flick of a fish's fin or the twitching of a human muscle, all creatures send out a stream of electrical pulses, and the shark's electromagnetic targeting system picks up on these signals. But this super sense could also hold the key to deterring deadly shark attacks. In the laboratory, scientists at the University of Queensland experiment with emitting low-level electrical currents. By identifying the electromagnetic frequency that sharks are sensitive to, scientists are able to design shark deterrents. The Shark Shield is a personal shark repellent device that exploits the shark's electrosensitivity.
The only device that has really been shown to be effective against white sharks particularly has been this electrical device known as the Shark Shield.
The electric pulse emitted by the Shark Shield overwhelms the electroreceptors of any shark that comes within a few meters. Suspended from a surfboard alongside a bait, the Shark Shield is put to the test. Before the device is activated, sharks circle the board, attracted by the bait. But when the Shark Shield is switched on, they scatter. The shark experiences a short burst of pain that passes when it swims out of the device's range, doing no lasting harm. The technology has been adapted to be worn by swimmers, surfers, and fishermen, providing a last-ditch defense against shark attack.
It appears that the Shark Shield is a viable option for surfers to use if they are going out in areas that are known to have higher shark densities.
But how can surfers and swimmers know if they're diving into shark-infested waters? In New South Wales, a mix of new technology is being used to alert people to the presence of sharks while preserving marine species. Older baited drumlines are replaced by high-tech, smart drumlines, which feed alerts to scientists via satellite.
SMART stands for Shark Mitigation Alert in Real Time. They're just alerting us to the fact that there's an animal on the line.
Rescue teams are able to quickly release animals caught by smart drumlines. Dangerous sharks are tagged with a transmitter and released out to sea. These tags provide scientists with crucial intelligence about shark behaviour.
So it's inserted in the back next to the dorsal fin, and for the next 10 years, that shark is able to be tracked when it comes past an underwater listening station.
A network of listening stations around Australia are linked by satellite, picking up signals from any tagged sharks within range and revealing startling new information about sharks' life cycles.
I mean, we're astounded. White sharks are traveling enormous distances. They're traveling on average around about 10,000 kilometers a year.
When a shark passes a listening station, surf lifesavers receive a message via a smartphone app. They're able to deploy specialized drones pre-programmed to identify the species and size of an intruding shark from the air and warn swimmers of the risk. With the help of technology, scientists are increasingly able to strike a balance between protecting swimmers and also marine life.
People are more prone to considering how we should be able to live with sharks while still enjoying the marine environment.
While electrodes